The system.configuration and the system.web.configuration namespaces both contain classes for manipulating configuration files at runtime. So the first of those is the system.configuration namespace. This contains classes that you can use for programmatic access to settings as well as to handle errors in configuration files. So the system.configuration namespace contains the redundantly named system.configuration.configuration class, which allows you to work with any configuration file on a particular computer, application, or resource. This object represents the merged view of configuration settings that apply to a specific physical entity, such as the computer, or to a logical entity, such as an application, or to a website. The specified logical entity can exist on the local computer or on a remote server. You have to have permissions, of course, to get access to the information. If there are no application-specific configuration files, then the object represents the default configuration settings as defined in machine.config or within the .NET framework. Because this object provides a merged view of the configuration settings, when reading the current value of the setting, you don't have to worry about whether it is a default value for the setting, defined in machine.config, defined in any of the hierarchies of the web.config files. It just doesn't matter where it's being read. The object just returns the current setting. And then, when you need to change the setting, if you're going to write to the configuration file, it knows which configuration file to write the setting to. You have a little bit of control over the process if you have a hierarchy of web.config files. But in general, it just knows where to put the information. You can use the Open Configuration method that the Configuration Manager object provides for client applications to work with configuration files. This method returns a system.configuration.configuration object, which in turn provides the required methods and properties to handle the configuration files. So a little bit later, you'll see lots of code that makes use of that technique. The other namespace is the system.web.configuration namespace. The Web Configuration Manager in this namespace is used specifically to configure ASP.NET applications. It exposes an open web configuration method that also returns a configuration object, and it includes members for accessing particular configuration settings that aren't as easily accessible via the generic Configuration Manager. So a large part of using the APIs is deciding exactly how to get access to the particular setting that you want to access. We're now going to look at some code that shows how you can access the app settings and connection strings elements in the web.config file. But one warning before we get into the code. Some of the examples demonstrate the classes and syntax that you can use to programmatically modify configuration files at runtime. This is useful for administering websites, but it's not something that you should put in any kind of application that any user can get access to. So to run the code, you would need to grant permissions to the ASP.NET or Network Service Process Model account, which would leave your application vulnerable to attack. Normally, you'd put this kind of code in some sort of separate administrative tool. All right, let's take a look at the code. Here's the web.config file and the connection string setting for the sample application. Again, we have a couple of connection strings defined, and now we're going to see how the code can access those connection strings in preparation, typically, for connecting to the databases. I'll go ahead and press F5 to run the application. And select the connection strings page. What the page does is it provides both ways of accessing the connection strings, either by the name defined within the connection strings settings, or I can also access them by provider. I'll go ahead and select the Northwind SQL, and that retrieves the connection string and displays it within the text box. I can select each of the other ones, and it reads and displays each of the connection strings in turn. So let's take a look at the code that accesses the strings this way. I'll go ahead and shut down the application so we have a little bit more room. Here's the code that executes for the selected index changed event procedure. This is associated with the radio button list name control. So this is going to show how we can retrieve the connection strings by name. The first thing the code does is it clears the selection of the provider radio button list. When the page posts back, it's going to be confusing if there is a selection in that section as well. So this just makes it unambiguous which connection string is currently being displayed in the page. The next thing the code does is it reads the text property of the selected item of that radio button list and saves that to the selected string variable. And then it executes the getConnectionStringByName method, passing in that string name. Here's that method. The first thing it does is it specifies some default string. This is what will be displayed just in case the connection string specified can't be found. Because the strings are stored separately in a web.config file, an administrator can go in and change the file and inadvertently delete a string that you want to access. So you always should provide a way for the code to degrade gracefully anytime you read configuration files. The next thing the code does is it instantiates a settings variable that is a connection strings setting collection. And then it uses the connection strings property in order to access the string with that particular name, whichever one was selected within the user interface. Now it's possible that the connection string with that name is not available, so we check to see whether or not that settings variable is null or not. If it's not null, then we read the connection string property and return that value. So that's all we need to do in order to display the connection string within the page. Here's the code for accessing the connection string by the provider. Similar to the previous example, we start out by clearing the selection of the radio button list for selecting the connection string by name. We read the text name of the provider that we want to retrieve, and then call this custom getConnectionStringByProvider method, passing in the name of the provider. And here's that method. We once again provide a default value in case we can't find any strings with that provider name, and then we get access to the connection strings settings collection using the Web Configuration Manager. Conceivably, this could retrieve multiple connection strings. So, after we check to make sure that the settings object is not null, we loop through each of the connection strings that was found and check to see whether or not the provider name matches the provider name that was selected in the user interface. And then we can read the connection string property of that object in order to return that value to the previous method. That shows just how easy it is to use the Configuration API to access different settings within configuration files. The flip side to reading configuration files is writing to them. ASP.NET lets you easily write to configuration files programmatically. You can use the Open Web Configuration method of the Web Configuration Manager class to open a configuration file for editing by passing a relative path to the file. In other words, you can specify which configuration file this setting is going to be written to depending on how you open the configuration file. You can also open configuration files in other applications by passing an IIS site name and a virtual directory, or open configuration files on another machine. However, there's a few caveats. Writing to configuration files at runtime is not intended for end-user applications. It can be useful for developers and website administrators when you need to modify configuration files programmatically, either locally or on a remote server. The current process requires write permissions on the file and the directory within Windows. By default, Network Service and ASP.NET don't have write permissions on application files and directories. You can work around this by using Windows Authentication and Impersonation, or by using a console application that runs under the user's identity. Using impersonation in a web application allows the request to execute with the identity of the user, provided the user has the necessary read and write ACLs in Windows on the files and folders. So you potentially have some fairly sticky security issues to deal with. ASP.NET by default will restart the application each time you write to web.config, creating a new instance of the application with a new app domain. So this may or may not be a desirable side effect to writing to files, and you need to be aware of it because it easily could mess up any existing users' sessions that are accessing the website. So let's take a look at an example of how you can write to a configuration file. Here you can see the app settings section of the web.config file. Just to point out again that in order to add an app setting, you use the add element and specify a key and a value for the element. You can retrieve the app settings value at runtime by supplying the key that is specified within the add element. The code that accesses this is in the appsettings.aspx page. So this shows how, within the page load event procedure, it uses the app settings property of the web configuration manager, passing in that key in order to access the particular setting. And then this particular code sets that value to the text property of the title label on the page. That's why when we run the application, the name stored within the app settings page tile setting appears at the top of the page. So let's see how this page works. I'll right-click on it and view in browser. The first thing I'll do is I'll enter a new session variable. And I'll save that in session state. This has created a variable that is now accessible as long as the user's session stays available. Typically, a user session remains available as long as the user is accessing pages from the site. But if they stop accessing pages for the default 20 minutes, the session state goes out of memory. So it's been a few moments since I did that, so I'll click on this button to display the value, and you can see that it displays the Hello Don text. So we still have a valid session, and that variable is still available. Now what I'm going to do is I'm going to create a new app setting name and value. So I'll once again be creative and call it new setting. And I'll give it a value of, here is a new setting. I'll save that new app setting, and that is now stored within the web.config file. I'll come back up here and display the session variable, and notice that there's no session variable found. Well, what happened? Well, you'll have to trust me that we're not doing any video trickery here, and it's really only been a few moments since I saved that session variable. Far less than the session timeout on this particular machine. But I changed a setting within the web.config file, ASP.NET saw that, and it restarted the application, thereby losing the session state for any users that were accessing the site. I'll go ahead and create another app setting. I'll leave the same name, but change the string a little bit. And I'll go ahead and save that. I'll go down here and list all app settings. And notice that we now have 2 app settings, not the 3 that you might have expected. We have the original page title setting, but we also have the new setting. But instead of multiple new setting keys, what the API did is it created a comma-delimited string of each of the values that I created. I can only have one app setting with a unique key value. So it just concatenates the values together like that. That may or may not be what you want, so in a real application you may need to test whether or not that setting currently exists and delete it if necessary. But in this case, we want to just go ahead and concatenate them all together. I'll close the browser and come back over into Visual Studio, which tells me again that web.config changed. Do I want to reload it? And sure, I do. I'll come back over to it, and we can see that we have that new setting with the comma-delimited list of values. Let's take a look at the code behind all this. I'll come back over to my code file here. And first take a look at the click event procedure of the Save Session button. All this does is it shows how you can create or update a session variable that is stored within the session state for the user. And I just read the text property of that text box. In order to display the session, I check first of all to see if the session variable is null or not. If it's not null, then I read that value and convert it to a string. I need to convert it to a string because the session object returns system.object objects. Those are generic objects, so I just need to read the string value of that. And then I format the string, passing it into the session variable value, and display that within the text property of the session label. Otherwise, if that session variable did not yet exist, or if session had been deleted for some reason, it displays that no session variable was found. The click event procedure of the Save App button is what takes care of creating that new app settings key. Now this code assumes that you entered a new key value pair on the page. So it starts out by reading the value of the name and setting text boxes, and then it opens up the web configuration file, and it specifically opens the root application web.config file. I know that because I pass in the tilde character, which references the web.config file within the root directory of this application. And I save that object to a config object variable of type configuration. Then all I need to do is get access to the app settings collection and the settings within it and call the add method in order to create the new key and value. And then in order to actually write the value, I call the save method of the config object. At this point, the web.config file is updated and the new setting takes effect for the application. And this is the code where, if the setting already exists, the configuration API will just go ahead and concatenate on the new value onto the existing value. When I want to list all the settings, I can instantiate a new string builder object and then use the Web Configuration Manager and the App Settings collection in order to get a reference to all of the keys within that collection. That key collection consists of name-value collection pairs, and I can use the App Settings property of the Web Configuration Manager to get access to all of those values. Then I use that array and collection in order to concatenate a string together with all of the keys and values from the App Settings section. So it's really pretty simple to read all of those settings from the web.config file.